Yes, anyone? Any confusion? Anything you want to ask? So you guys understood, right? Last two experiments. So next Monday we'll have our civil. Yes, sir. But next Monday there is a test one. Yeah, test one will be there in your class, right? It is not a whole day you have test one. Only in that class hour you will have that subject test one. So yeah, so in this, so next Monday you have lab hour, right? That 11th hour, 11:15 to 12:20. So in that time we'll have a small quiz. So just nothing, just two experiments we covered, right, in the last uh, 2 weeks. So today we'll be conducting our third experiment. Anyway, this experiment is not there, not included in the quiz. So first two experiments, this is the aggregate shape test, and then we discussed about that last earth water absorption and specific gravity. So these two will be the, I mean, syllabus will be there only from these two experiments. So 12, 15 questions will be there, and you will have only 10 minutes to answer. MCQs will be there, all 15 MCQs. Okay. So that anyway, I'll post it in the, I mean, in the, you will get email also. I'll send email to all of you. Okay. Yeah. So before starting today's class, anyone has any confusion? Anything, any doubt to ask? Yes. So if you guys don't have any doubt, then maybe we can start in this leg experiment. So today we'll be performing a sieve analysis of codes aggregate, right? So in last classes onwards, last two classes, we are discussing about the properties of aggregate, right? We are finding out different properties of aggregate by first one we discussed about that aggregate shape test, and last class we discussed about water absorption and specific gravity, right? So in this experiment today we'll do our third experiment. There is a sieve analysis of codes aggregate. So just make sure this codes, whatever I just presented, right? This is not this codes. This is COARAC, this codes, right? Which is a big that we call it. So sieve analysis of codes aggregate. So that experiment will do it. So it is a very simple experiment. Within the sieve only we can find it out what grade of aggregates are present. So it is 20 minutes experiment. So I'll just play the video. So after the video, I'll explain if you guys have any doubts and all. Okay. Okay. So I am playing the video.
So last class we have discussed about aggregates, how to find it out the specific gravity and water absorption of aggregate. So in this class we'll be discussing one more experiment on aggregate, that is the sieve analysis of codes aggregate. So if you recall, we have started our this codes, this lab experiment for civil. We listed total 10 experiments, out of which 6 will be the basically physical experiments, and remaining 4 will be MATLAB based experiments. So experiment 1 we discussed about the shape test, because aggregates we are studying in details. Aggregate is one of the main ingredient of the construction industry. So if you do any construction, we use aggregate extensively. So before using aggregate, we have to understand its properties. So that's what we started understanding the aggregate properties. We discussed about the shape test, and then in the last class we discussed about the specific gravity of aggregate and water absorption of aggregate. So in this class we'll be discussing about the sieve analysis and sieve analysis of this. Just excuse me, this is not codes. This is codes. Codes means a bigger size. Codes aggregate. Okay, so which is large dimension in nature. So these are the aggregates basically you will find in a field, in a construction site. So how the aggregates are actually produced. Aggregates are basically igneous rocks will be there on a site. From a hillside they cut the big pieces of stones, and then using this type of crushing machine will be there in the site. Using this crushing machine, basically these big small pieces of stones will be disintegrated into small stones, small chips like that. This we call it basically aggregate, and this is specifically coarse aggregate. Even sand also we use for the construction purpose. So sand is also a type of aggregate that we call it fine aggregate, which is fine in nature. And this aggregate is a coarse aggregate, means large in dimension. So aggregate more than 4.75 mm diameter, we call it is a coarse aggregate, and aggregate less than 4.75 mm diameter, we call it is a fine aggregate. Okay, so these are actually the coarse aggregate. Today we'll be discussing about the sieve analysis of coarse aggregate, which is, dimension is more than 4.75 mm. So now, so if you see in a site, this type of crushing machines are available. In this crushing machine, basically, these big stones are kept and it is broken into small parts. Okay. So now, if you see in this portion, so for some construction purpose, we need 20 mm diameter of size, or some construction we need 10 mm diameter, in some construction we need 6 mm diameter chips, like depending on the use. Like if you see in the railway lines where the ballast we keep besides the railway track, that diameter of that dimension of that aggregate is quite large, right? 20 mm, 30 mm we use. Even for the road construction also, when we make our subgrade soil, that time we use bigger dimensions of aggregate, right? But when we construct the slabs or the beams, columns, that time we use that lesser dimension, maybe 20 mm diameter or 12 mm diameter size of aggregates, right? So while crushing the aggregate, we have to get proper size of aggregate, because which is required in our construction purpose, that only we should make, right? So on a site, when we have the aggregate, it will be mixture of all different types of aggregates. You cannot get all aggregates are of 20 mm diameter or all aggregates of 12 mm diameter, because it is prepared in a crushing test machine. So in the crushing test machine, basically all the different types of grades, sizes of aggregate will come out. So in that sense, if you need 20 mm, so you may not find all aggregates will have exactly 20 mm diameter. Some will be 25, or some will be 16, 15, 10 also you will find. So in this experiment, we'll find it out a particular grade of concrete, how we can call it is a 20 mm aggregate, or it is a 16 mm aggregate, or it is a 10 mm aggregate, how actually we can classify the aggregate. Because in reality, aggregate you will find even in 20 mm grade of concrete aggregate also, you will find some will be smaller dimensions. So that's what we'll do it. We'll perform a sieve analysis and we'll find it out, what is the grade of, what is the dimension of the particular grade of aggregates. So the apparatus required for this experiment will be, we will be using simple balance and the sieve sets, and then the aggregates. So sieve sets will be using 20 mm, starting with 20 mm. At the top will be 20 mm, then we'll use the 12.5 mm, then 10 mm, then 6.3 and 4.0. Like that, we'll stack all the sieves and then we'll perform our experiment. So the this is the table. Basically, once you perform the experiments, you will find this type of table will be available. So in that, basically, again we are finding out which type of aggregate has actually passed through each sieve. So basically, we'll put all 1 kg of aggregate, we'll take from the sample 1 kg of aggregate, we'll measure this using the balance, and we'll keep all the samples into the top sieve. So top sieve is 20 mm, then 12.5 mm, 10 mm, 46.73 mm, like that. We'll one by one we keep our sieves, and then 1 kg of sample we'll take it and we'll keep it at the top means 20 mm sieve, and then we'll do the shaking, that is sieve and sieve shaking will do it. So then all the smaller dimension aggregates will be passing through the each sieves. So some sieve, some particle will be there at the top, means the dimension is more than 20 mm, that will be retained at the 20 mm sieve. Now some will be at the 16 mm level, because those two dimension in between 20 to 16 mm, that will be retained in the 20 mm sieve. Like that, all sieves will find the aggregates are retaining. Now 1 kg is total we have taken, and each portion we are taking, few samples will be reduced. So now we'll collect it from each sieve, how much is retained, and we'll measure it out, and then we'll make a table, like in each sieve how much is passing. Okay, so based on how much is passing in and how much retain in each sieve, then we can conclude that which sieve, which type of aggregate that is. So this table you will find it out in the IS Indian Standard 383/1970. So in that year, this IS code has written. So in that IS code you will find it out. For example, if you tell the 20 mm grade of aggregate means these are the criteria should be. So in a 20 mm grade of aggregate, all that 85 to 100% should retain in the 20 mm sieve, but 40 mm sieve all should passing. So like that, the criteria they have given. So if we'll find it out, we'll first we'll do the experiment, and then we'll measure, we'll check with our values with this table which one is matching, and that will be corresponding to the size of the aggregate. So for example, if the 63 mm, that is a very large dimension of aggregate, if you take, in that case, all aggregate should pass through 80 mm sieve. Okay, but in 63 mm sieve, 85% should retain. Then in 40 mm sieve, 0 to 30%, if it is retaining in 40 mm sieve, then also we'll consider it as a 63 mm diameter of aggregate. So that is the experiment we'll be performing in the lab, and then we'll be tabulating our values, and we'll match it with which category our current sample is matching, and that will be corresponding to the final grade or final dimension of the concrete aggregate. Now let's go to civil engineering lab and let's perform. So now we are into civil engineering lab. So for this experiment, we need aggregate sample, we need balance, and the sieve set. So again, sieve sets are kept in a sequential manner. At the top 20, 16 mm, then 12.5 mm, 10 mm, 6.3 mm, and at the bottom we have the pen. So this is the total apparatus required to perform this experiment. So now we will take the 1 kg of sample, aggregate sample, in a balance, and we'll find it out. So here you can see we are collecting the exactly 1 kg of aggregate sample from the total aggregate. So now it is exactly 1 kg of aggregate that we are keeping it into the top of the sieve. So this entire aggregate will be sieved, and then the smaller particle will be retained in each sieve, and the smaller particle will be passing in each sieve, and the larger particle will be passing from one sieve to another sieve. So we just keep close on the top of the sieve, and the base we have the pen. So if you see, all the sieves are placed in a sequential manner. So at the top we have the Courtsire grade, that is 20 mm diameter, and then we have 12.5 mm diameter, then we have 16 mm diameter, 10 mm diameter, then 6.3 mm. So total, these are the different grades, different size shapes we are keeping one by one. Then properly we have to shake it so that all the particles should pass through the respective sieves. So now you can see all the sieves, how much aggregate is passing in each sieve from 20 mm to at the end, at the pen. So all the sieves, now we will take one by one measurement and find it out in each sieve how much aggregate has retained. So now you can see, we'll be one by one, we'll be doing the finding out the how much aggregate is retained in each sieve. So now we set the balance to 0. That is, make sure that every time when we take any balance, initial reading should be 0. Then all the one by one we are keeping the samples and finding out how much is the weight passed through that sheet and the value that recorded in the table. So this one is the larger one, that is the 20 mm. See how much it is retained, that is recorded in the balance, and we are putting it in the observation book. So this first sieve is over. Now next, like that, one by one, all sieves will be getting out how much aggregate is retained in each sieve. That basically we are finding out and we are recording in our observation sheet. So this is our second one, that is a 12.5 mm sieve. Make sure that all the samples you are collecting from the sieves, and then you are finding out how much is the total aggregate retained in the sieve. So the second sieve is over. Now we will take the third sieve, that is 10 mm sieve. This is is the 10 mm sieve. So like that, all the sieves, we have to find it out how much total aggregate has retained. All the values will be recorded in a table. So after the experiment, we just captured all the recordings, whatever we have done. So all the sieve records are there. How much aggregate is retained in the each sieve are here tabulated below. So in this table total, we have taken total 1 kg of sample. So in that 1 kg of sample, basically the 20 mm to 16 mm. So different sieves we kept it. The top was 20 mm, 16 mm, 12.5 mm, 10 mm, 6.3 mm, and at the bottom you have the pen. So this is a total sieve assembly. We kept it. Then at the 20 mm total 248 gram total aggregate is retained there. Then in the 16 mm 250 gram aggregate is retained. Same 12.5 mm 156 gram aggregate is retained. 10 mm 100 gram, 6.3 mm 170 gram, and in the pan at the bottom also 53 gram, that is dust particle and small aggregates are actually retained. So if you add it all, you will get a total of 1000 gram of total sample. So like that, basically when you perform the real experiments, real life, then at least we have to take the three measurements. So this is one measurement, then with another samples, in the same bucket, same another grade of sample, we'll take it and then we'll do it second measurements, and then we'll have third. So we'll take all these threes average, and then we'll find it out our final value. So here you can see that these are the average values we got it. So here only single experiments we have performed, so we just place the same value, but in real life we have to minimum perform the 3 experiments. So now this column is basically percentage of total weight retained. So in each sieve, how much aggregate is retained. So the first is 248 gram has retained, right? So the percentage weight retained is total was 1 kg, that is 1000 gram. So 248 divided by 1000 into 100, which will give you 24.8 gram of sample retained at the 20 mm sieve. Similarly, at the 16 mm sieve, 250 gram, which is nothing but 25% of the total aggregate is retained. So like that, all the values we are keeping it in this column. So next in this column, that is cumulative percentage of total weight retained. So this is cumulative. Cumulative means total how much retained in the 20 mm, total how much retained all above the 16 mm. So like that cumulative, basically we are finding out. So this is nothing but 20 mm is the first one, so all that is 24.8 same. But at the 16 mm sieve, basically it will be cumulative, means 20 mm it retained 24.8 percent, and in that 16 mm it retained 25. So we have to add these both, and then that is the total percentage of aggregate retained at the top level, I mean at the 16 mm level. Similarly, for the 12.5 mm sieve, if you see, the total cumulative retain will be 49.8 plus 15.6, the total it comes out to be 65.4. So like that we have to find it out the cumulative one. So this one will be 75.4, will be 65.4 plus 10, which is nothing but 75.4. So like that we have to find it out the cumulative retained, how much cumulative retained in each sieve. So at the last, basically all are actually retained, right? This is 100%. And this percentage, this column is basically percentage passing of each sieve. So if you see at the first 20 mm sieve, only 24.8% retained, right, at the top sieve. But how much is passing then? The remaining 75.2% is actually passing. Like that, similarly, 16.6, 16 mm sieve, total 49 is cumulatively retained. Then how much is passing then? Passing is 50.2, right? This 100 minus this column basically will give you this column. So now we got it in each slab or each sieve, basically how much is passing. So once we get this chart, this is how much is passing. So now based on this value, basically we can classify the aggregate under in which category, either it is 20 mm sieve or 20 mm aggregate, or it is 16 mm or 15 mm, whatever it may be. So once we get this type of tables, then we'll use this chart as I shown you earlier, that is IS 383. You will get this chart. So here you will see different categories of aggregates are there. So for 16 mm, almost 85 to 100% should retain at the 16 mm, whereas at 10 mm 0 to 30% will be retaining. So like the 12.5 mm aggregate, single grain aggregate, it will have 100% should retain at the 16 mm. So but in our case, our aggregate is in this range, so 20 mm range, actually 20 and 16 also, both in middle basically. So our aggregate is basically in middle, so 15 or 16 to 20, maybe 18 mm in diameter you can consider. So like that, basically we have to perform the experiment in lab, and then we have to interpret the result using this chart. So this chart is available in Indian Standard 383. So in that code, basically we'll get this table. So like that, in any sample, basically we have to trial 3 times. 3 times we have to repeat the experiment, and then we'll find out what is the average value, and that will match it with which column it is matching, and corresponding to that, that will be the nominal size of the aggregate for that will be used for the construction purpose. So in this experiment, basically we have learned how to find it out the nominal diameter of aggregate using the simple sieve analysis. So this method is only useful when the aggregate is quartz aggregate, means the nominal diameter of the aggregate is more than 4.75 mm diameter, then we can perform this experiment. So in the next class, we'll be starting our new experiment, that is on surveying. So basically in aggregate, we completed 3 experiments. First one was aggregate shape test. Next we performed aggregate water absorption and specific gravity test. And in this class we performed the finding out the nominal diameter of the aggregate. So in the next class onwards, the next 3 experiments will be surveying experiments that will be discussed in the next class. Thank you.
Yeah, so anyone has any confusion in that experiment? Yes?
So the groups that we were divided into, are they permanent for all the experiments, sir?
Yeah, that you are talking about sieves, right? Sieve setting you are talking about. Hello? Can
No,
you
sir,
hear
I
me?
was talking about the groups we were divided into for the report.
Groups, okay. That I'll explain, yeah. That we'll discuss after that. First, let me know if you have any confusion in that experiment, in the student's experiment.
Okay, sir, no confusion in the experiment.
Okay. Others? Others, any confusion?
No confusion, sir.
Okay, so what we discussed is basically we are finding out so which type of aggregate it is, right? So when you are constructing a structure, different beam column will be there. So each portion will be using sometimes different grade of aggregate. Sometimes we use 20 mm, for foundation purpose, 20 mm C, 20 mm aggregate. Then for the slab purpose, maybe we may use 12 mm C, 12 mm aggregate. So and even for highway constructions, you will find at the bottom of the highway we give large big boulders. Similarly, for other railways, tracks and all, we give big boulders, 63, 80 mm aggregate. So how to find it out which grade of aggregate it is? Because when you
make the aggregates on a site, this type of crushing machine will be there, right? So in this crushing machine, basically, we put all the stones, and in that crushing machine, the stones will be broken into small parts and aggregates we are getting, right? Then each aggregate will have different shapes, right? If you set the value in the crushing machine 20 mm, like all the aggregates will be coming out from this crushing machine 20 mm. Then, but in output, if you see, all aggregate won't be 20 mm. Some will be 16 mm, some will be 25 mm. So these variations will be there. Okay, so in this method, basically in this sieve analysis method, basically we are finding out how to finding out what is the nominal diameter size of the grade. Then we tabulated all these values, and then we got it, what is the size. Then we verify whatever value we get it with this IS code table. So this table is standard table. In that IS 383 will get it this table. So all the values will be there. For example, if the nominal size of aggregate is 16 mm, then this column you should get it. If the nominal size of aggregate is 12.5 mm, then this column of value you should get it. So once we find it out, experiment with the aggregate, and we find it out what is the average percentage of aggregate retained in each sieve, then these values are compared with this table value, which one it is matching. That corresponding to the nominal value, we will tell that this type of aggregate is, as the nominal aggregate size is that much. Either it may be 63, 40, whatever it may be. So that's how this experiment is. Yeah, so anyone has any confusion in that? Yes? Anyone?
No, sir, it's clear.
Okay, Pujita, it is clear. Others? Nitin, I could see many has joined, 125 student. Yeah, so we have completed 3 experiments in civil. So total, these 3 experiments were of aggregate. So we are discussing about the aggregate properties, right? Then in the next 3 experiments will be from surveying. So what is surveying? Surveying means, like, before you do any construction, we have to first make the plan, right? You have to measure how much area you have. If you're constructing a building, then you have to find it out how much area is available for construction, and whether the site is plain or in some portion there is a up hill types is there. So all these things you have to find it out, right, before the construction. That we call it surveying. Okay, even for road construction also, you see, when you go to any site where the road construction is going on, some surveyor will be there. They will be measuring all the elevations, heights, width, everything they will be measuring. So that is surveying. So next 3 experiments we'll be discussing that surveying equipment. We'll see how to find it out elevations and all, how to find it out areas, right? So all these basic things we'll be discussing in the next 3 experiment. So that is our next 3 experiment, and then last 4 experiment will be the MATLAB based experiment. So I think other courses you started MATLAB, right? You are getting understand about the basics of MATLAB, right? How to do operations and all. So we'll be doing MATLAB later on. Last 4 experiments will be MATLAB based, and remaining are these physical experiments. Okay, so no one has any confusion? Okay. So if no one has any confusion, then yeah. So I have just posted in the LMS, you can see total 3 experiments we covered. All the 3 experiments you will get. I think 2 already I posted. And in this experiment, I will post it now. And the quiz will be on next Monday. That is on 22nd. Okay, that is for 10 minutes. 15 question will be there, MCQ questions. Okay, so 10, I think I have set time 11:55. So next Monday, 11:55 to 12:10. So last 15 minutes or 10 minutes we'll have the quiz. I thought of conducting by today, then I saw that mail, right? That Nayar sir has mailed that the electrical science quiz you are having today. Then today morning I spoke with him. He said by mistakenly he put it 15th, it will be 16th. So I think he has changed. So tomorrow you will have the electrical quiz. Anyway, our civil quiz will do it on next Monday. So just first 2 experiments. So this experiment is not included. And I have added the manual also, that lab manual for the 2 experiments, I think. So, and you have to upload the manual also, some demo observations, also data also given to you. So total, I think 5 groups we have made. So you just check your respective observations of each group. Okay, and write the report and upload the PDF copy of the report. Okay. Yeah, so anyone has anything in uploading assignments and all reports? Yes, Pujita, you said something, you have some doubt. Others?
Yeah, sir. I had a doubt about the groups, sir. In the report, I just
Groups
checked
are
the
just randomly made. So we also just in Moodle we can make random groups. Total I think 320 students at that. So randomly 5 group they have made. I also don't know in which sequence they made. But anyway, you already got it, right? If you have in particular group that value only, you will get it. Okay. Sir, upload lab manuals. Lab manual already uploaded for one experiment, and remaining 2 I'll be uploading now. One experiment already I uploaded. First experiment, the shape test. And all the YouTube videos also you will get it in the LMS. Everything is up to date except the manual 2. Manual 2 I'll be uploading now. Yes, anyone? Any confusion? Anything want to ask? No? Madam, Manisha madam, want to say anything? Okay, I think Manisha madam is not there. Okay, anyway, sir, can you repeat the process of assignment again? Yeah, sure, I'll repeat. Let me just share the screen then. Okay, share my screen. Okay. Yeah, so now you can see the screen, right? So once you go to your LMS, in that engineering measurement codes, let me, yeah, so once you come to this engineering measurement codes, this type of page dashboard, you will get it. So in that civil category, civil engineering folder, actually we are reading all the civil related stuff. So once you go to civil engineering, then you will find it out the sample copy of lab report. Just click on it and download what is that content. I have to share maybe entire screen. Let me share my entire screen. Yeah, now I have shared my entire screen. Yeah, now you can see that once you download this first one, the simple copy of lab report, then this type of word will be downloaded. Here you can see this is a template how you have to make the reports. So your name, roll number, batch, anyway, experiment number, name, apparatus, all these things are there, results. So this is the basic template you have to follow while writing the report. So this is first one is template, you will get it. Next one is this experiment one is the recorded video, that YouTube video link is given. Once you click it, you can see that. And class one means when we had class on 1st February, right? That class recordings, you will get it in this link. And then this is the manual for experiment one. So once you click it, one PDF will be opening. So this is our first experiment, right? That shape test, whatever we did, all the tables and all will be there. Similarly, elongation index, manually will get it. Okay. So yeah, so this is the manual and these are the 5 assignments. So I think you will be seeing only one assignment. So which group you are belongs to, either it can be group A, group B, group C, group D, group E. So total 5 groups I have made. I think when you log in from your login credential, you will see only one assignment. You won't see 5 because I have created so I can see all 5, but you can see only one group, whichever you are assigned to. So once you go to that assignment, you will find each group, you will find something like that. Observations for flakiness index. This is a demo of the observation given. Okay, so one experiment I performed in the video, right? That is for the that is our performance what we did in the lab. But this is the demo value is given to you. You use this value and find it out the calculation. You do the calculation, you make the observation report, and then you submit it. That is for the flakiness index, and this table is for the elongation index. Just demo value is given. So make sure that all 5 group actually has 5 different values, observation values. Okay, so everyone has to do it. And then you have to upload it. Okay, somewhere you will have some option to upload. So you can upload it. So this is the deadline is given 23rd February. Okay, so by next Monday, next Tuesday. Before that, this one you will get it. Similarly for experiment 2 also, I'll upload the manual now, and this assignment also I create. Assignment is nothing but you have to upload the reports. So similarly 5 group will be there and 5 readings I'll be giving you. Okay, and this is class 2, experiment 2, recorded video, experiment 2 class video, and this is the quiz one. Already I have scheduled. So next Monday actually. So okay, so this is scheduled on Monday 22nd on 11:55 to
12:10. So it is actually 10 minutes with quiz. 15 questions will be there. That will be allowed on next Monday. So yeah, so this is the thing. So you understood the assignment progress? I mean, how to upload the lab report? Anyone has anything to ask? Yes, okay. Others? No confusion. Okay. So if you don't have any confusion, please watch at least first 2 videos experiment, because that will be a syllabus for quiz 1. And searching Google in the internet also, you search, read it as much as possible about these 2 experiment, because question will come, from every aspect of this experiment. Okay. Okay, so no one has anything to ask, then maybe we can, okay, what he asked, sir, how do you know that how many are there in our group? No, group means what? Group means you have to do it individually. It is not like group. Okay, so you have to do it your own calculations, all manuals. Okay, it is not like group project, like all, 60 students will be submitting one lab report. No, that is group I made for, I want to give everyone has a different value. So at least every 5 of you will have different value. Okay, so you have to do it. Calculation, you have to do it by yourself only. Values are there, observation values are given in the assignment, each assignment. Okay, so maybe, so just don't copy paste, because both the groups will have different observations and different, that values and all. If you copy paste, you will get 0 simply. Sir, should we be writing or typing the assignment? Okay, no need to write again. Why to write again everything, and again you have to take screenshot. Just copy paste from the manual and make your report. But observation, you have to do it. Calculation part, you have to do it, everyone. But for writing purpose, no need to write. Okay, just you can copy paste also, no problem. From manual you copy paste, and but table you have to make it anyway. Yes, anyone? Anything want to ask? No. Okay, then I can close it off the session. So we'll be again meeting on next Monday. So, yeah. Sir, can you tell us again how to check which group I am in? No, just log in in your LMS. Okay, just log in your LMS. Go to the folder, civil engineering folder. I think you will get it only one link. You won't get all 5. Which group you belongs to, only that you will get it. I don't know, I can do it or not, but once you log in your credential, you will get it only single. Just check it. When you log in your credential, you will see only one. So that group you belongs to. Okay, fine then. So that's no confusion, means I am closing this meeting then. Okay.